Hey everyone, it's Amir Ali. Welcome to Code and Cadet by Sam. Today we are diving into one of the key patterns for managing data consistency in distributed systems, the SAGA design pattern in microservices. If you are preparing for microservices interview, then this question is most repeated question which will be asked. Before we jump into the technical details, let me give you a quick overview of what we'll be covering in this session. We'll begin by understanding how simple ACID transactions work in monolithic applications. This will give us a baseline to compare against distributed systems. Then we'll define what the SAGA design pattern is, explaining how it works and why it's important in the context of microservices. Next, we'll discuss the challenges developers faced before SAGA, especially when trying to manage data consistency across multiple services. And finally, we'll see how the SAGA pattern addresses those challenges by breaking down large transactions into smaller, manageable steps while ensuring eventual consistency. This will give you a clear picture of why SAGA is such a powerful pattern in modern microservices architecture. Let's get started with the first topic, ACID transactions in monoliths. Before we understand the SAGA design pattern, first let's understand it with a simple monolithic e-commerce application architecture. Here, all the business functionalities like order processing, payment, inventory, shipping, and so on are bundled together into one single application. All the client devices, whether it's a web app, mobile app, or even a browser, they send HTTP requests to this centralized monolithic application. Now this application processes the request, runs all the related operations internally, and finally talks to just one centralized database at the bottom. Let's walk through a typical flow. Say a customer places an order. Now inside the monolithic application, here's what happens step by step. First, the order is created. Then the payment is processed. After that, the inventory is updated, and finally shipping is arranged. Since all these modules are part of the same application and they use the same centralized database, all these operations are wrapped nicely inside a single ACID transaction. That means either everything succeeds or everything rolls back, keeping data consistent automatically. Now imagine something goes wrong in the middle of the process, like the payment goes through successfully, but when we try to update the inventory, it fails. Now the question is, does it make changes in the database or not? The answer is no, because the entire flow is part of a single atomic transaction. And what does that mean? Atomic means either everything happens or nothing happens. There's no in between. So when that inventory update fails, the system automatically rolls back everything. That means the order is not saved, the payment is not captured, no changes in inventory, and no shipping is arranged. Your database stays clean, like nothing ever happened. That's the magic of ACID transactions, especially the atomicity part. Everything is handled together as one solid block, so your data always remains safe and consistent. Alright, so now after our previous discussion, let's talk about what the SAGA design pattern is in microservices. Well, imagine you have got a big business process that touches multiple microservices, like placing an order, reserving inventory, and processing payment. In a monolithic app, this would be one nice big transaction, but in microservices, each service has its own database. So doing one big transaction across them is just not possible. That's exactly where SAGA comes in. SAGA basically breaks that big process into smaller local transactions, each handled by a different service. Once one service finishes its part, it either publishes an event or calls the next service in the chain. And here's the best part, if something goes wrong at any step, the whole system doesn't just fall apart. Instead, it runs compensating transactions, kind of like pressing undo step by step to reverse whatever was already done. So in short, SAGA helps microservices keep their data consistent without using those heavy, complex distributed transactions. Before we jump into the SAGA design pattern, let's first talk about what were the key challenges in microservices without SAGA. So here's a simple scenario. First, the order service creates a brand new order in its own database, and then it calls the payment service. The payment service happily deducts the payment, and then it calls the inventory service to reserve the stock. But suddenly the inventory service fails. Maybe the item's out of stock, maybe there's a system error, whatever the reason, the reservation doesn't happen. Now here's the problem. The order is already created and the payment is already deducted, but stock couldn't be reserved. Without SAGA, there is no easy way to roll back all those previous steps across multiple services. And now we've got a serious problem. The order was created, the customer was charged, but the inventory step failed. So basically the user just paid for something that can't even be delivered. This leaves our system in a totally inconsistent state. The order can't be fulfilled, the user's money is gone, but no product is on the way. And the whole system's data is now out of sync. This is exactly the nightmare scenario we want to avoid. The customer's now frustrated, really frustrated. Your support team completely swamped with refund requests. And the worst part, users start losing trust in your system. Angry customer, support team stuck handling refunds manually, and slowly your reputation takes a hit. So why does this actually happen technically? Well, in microservices, each service has its own database, totally separate. There's no big global transaction holding everything together. So if one step fails, there's no built-in way to roll back what already happened. Each service is just doing its own thing, acting in isolation with zero coordination, no shared transaction across services, no rollback logic on failure. Services acting in isolation. Alright, now not on this screen, we're talking about the failure case. Here I have added the SAGA design pattern in action. So first let's take a look at the happy flow of SAGA, and then we'll talk about what happens if any service goes down. By the way, orchestration is basically a type of SAGA pattern in microservices. Now this is when everything works perfectly, no hiccups at all. The client sends a request, I want to place an order for product A. The orchestrator gets that request and says, alright, I'll manage the whole thing. First stop, order service. Please create a new order. Order service does its magic and replies, order created. Next, the orchestrator calls the payment service. Great, now charge the customer. Payment service processes it and replies, payment successful. Then the orchestrator calls the inventory service. Now reserve the product from stock. Inventory checks and says stock reserved. Since every step went through without a problem, the orchestrator sends a message back to the client. Order placed successfully. And boom, process complete. Customers happy, life's good. Alright, now let's talk about the failure case. What if the inventory service goes down? How does orchestration manage that? So everything's going smoothly at first. Order is created, payment is successful, but then boom, inventory service fails. Maybe the product's out of stock, maybe the service itself just crashed. Now here's where the orchestrator earns its paycheck. It instantly detects the failure and says, hold on, we are not leaving the system in a broken state. Instead, it stops the workflow right there and kicks off the compensation process, rolling back previous actions so things stay consistent. The first step in the compensation process is to undo the payment. The orchestrator sends a command to the payment service, hey, please refund the customer. The payment service jumps into action, processes the refund and confirms back, payment refunded successfully. So now the customer's money is safe and they are not charged for something we can't deliver. Next, the orchestrator sends another compensation command, this time to the order service. Hey, please cancel the order. The order service updates the database and marks it as cancelled. Finally, the orchestrator gets back to the user. Sorry, your order couldn't be placed, but don't worry, you haven't been charged. So yeah, even though something went wrong in the middle, our system stayed consistent and, more importantly, trustworthy. Quickly wrap this up and see how the SAGA pattern handles failures in an orchestrated workflow. It all kicks off when the inventory service fails, maybe because the stock's gone or the service itself just decided to take a nap. The orchestrator instantly spots a failure and says, nope, we are not going any further. It then fires up the compensation process. First stop, the payment service. Please refund the customer. Refund goes through, no money lost. Next, the order service gets a call. Cancel order. Database updated, order marked as cancelled. Finally, the user gets a message. Sorry, your order couldn't be placed, but don't worry, you haven't been charged. So yeah, even if a service fails in the middle, the SAGA pattern rolls everything back nice and clean, keeping the system consistent and the customer experience smooth as butter. Do you have any questions? Leave a comment below. I'd love to hear from you. And if you found this helpful, do support the channel by hitting like and share. Don't forget to subscribe for more upcoming videos on microservices, Spring Boot and other tech topics. Thanks for watching and see you in the next one.